Okay, couple items. One, like I said, no daily check because I want to get more practice with Goss Jordan. Two, I'd said some of us are directionally challenged here. Everything in these two right piles, the chapter 4 and 7 packet turn in, just take them. Okay? The last 2 weeks have been nonstop chaos. I really feel bad for my third hour who has not had an in-person lesson in like a week and a half. Almost 2 weeks. So what I'm going to do, since I just don't have that time, normally by this point in the year, there's like 2 or 3 kids who just decide they're not doing stuff. And they, like, half of their packet is empty. They never do any assignments. Their daily checks are just copied from the board, and I know it's BS, so I give them zeros anyway. Like, normally we got 1 or 2 of those, right? We got none. Like, I know there's some shadiness, and there's always going to be some shadiness, but for the most part, y'all are doing what you're supposed to, and that's great. And you've been putting up with my personal life circumstances spilling into the classroom for too long. Chapters 4, 7, and 6 I am putting in as full credit for everyone. Nope, I don't want to see them because I ain't going to look at them. I'm putting those in as full credit for everyone, assuming that if you just decide you don't want to do stuff for this last week, you know what happens on tests, right? You know what happens on tests. And the number of you in here who are so freaked out about the potential for hitting a 91.9, which happened to like half of the kids last year, spring semester. Okay. I hope that means that you're going to continue to do what you're supposed to. It's just, I want to give you all the benefit of the doubt because so far you've been doing solid in here. Performance-wise, across the board, y'all are doing great. So the chapter 4 and 7 packets, just pick them up. I'm going to throw them in as full credit. Personally, I believe we shouldn't have to do any of that anyway. In previous schools, I just did the test and that's it. Either you're doing what you're supposed to on the side or not. Okay? And that's how it is in a lot of college courses. The majority of them, actually. So, you've been doing great. I'm going to put those in as full credit for everyone. If you were someone who didn't do what you were supposed to, yeah, you're getting off the hook. If you were someone who did what you were supposed to, yeah, you get your 100. Remember that grand total, your daily work is like 10% of your grade. Like, it's not much. It's barely moving the needle. It's the quizzes that matter. That's why they're open notes, open everything. That's why we review it beforehand. That's why I give you all the resources, because there you are truly showing me what you know. Okay? So, the 2 piles to the right, you can go pick those up, take them. I don't want to see them. Same thing with the chapter 6 packet. I don't want to see it. Don't even bother turning it in. Okay? Now, the chapters 0, 1, 2, and 3 stuff, if you still have that blank in the grade book, I need to see that because I went through everyone else's. Fair's fair, I got to go through yours. And I don't have due dates except the 26th. Okay? There is that due date because that's kind of when you have to. So, if you are still missing an old packet, turn them in, but 4 and onward, I don't care. I'm giving everyone full credit. Call it good. Who do what? In old packet turn-in pile. Maddie, I think yours was like chapter 2 or something. Okay. All right. Now we left off with, did we go through this one? I know we did it. I don't remember if we went through it.
No, we did. You showed it. You showed like a different.
Okay.
I'm pretty sure you were showing us a different method.
I was just showing you that you don't have to work your way around the loop. You can choose with Gauss-Jordan to just work on one column at a time, whatever you feel like. Okay? So, so we did not get to 3. 3 is going to be tough because you are not getting out of this without undoing one of the zeros that's already there. I mean, you are not going to be able to -1, 3, 12. You are not going to be able to use this to get rid of this without undoing this 0. Because look at the value below it. You are not going to be able to use this guy to get rid of this guy, like 4 row 1 plus 5 row 3. You're not going to be able to do that without undoing this 0. Okay, because of the way the zeros are staggered in each row and column, you're going to have to break the egg to make the omelet. Okay? So, with that said, I want you to just stick with the pattern. Use this to eliminate these 2, then eliminate this guy, then eliminate these guys, then eliminate this guy. Go around the block. Okay? If you just stick with that pattern, it will work every time. It might involve a little bit more work if you stick with that because there might have been a more efficient way, but just run with it. Okay? I'd like all of us to give number 3 a try. See what we got. Yeah?
So for this, can we like make those both 20 and then like do?
Yeah, that's part of
Okay.
what I would do if you're trying to do that is just take the bottom row times 5 to begin with.
Okay. Oh, and then do like a separate.
Then
Okay.
go.
Yeah.
Yeah.
You have to get rid of the 5.
No, you can work with a -5 up there. It's just we've had a 1 there in every problem we've done so far. Now it's not. What do you do? Okay. So could I right away say row 1 plus row 3 to have a -1 up in that spot and then go? Because now you got a 1 up in that top command zone. You don't have to. But can I do this? Yeah. Just watch that you're doing it with every single term in there. Yes. That's what we're practicing today is with Gauss-Jordan, as long as you're following the rules of the road, we don't care how you got to Walmart. You might have taken a detour through Gillette. Whatever, you still got there. Okay? You can add any 2 or more rows together. You can multiply any row by a constant. You can add any multiples of rows together, and you can switch rows. Those are the 3 rules. So long as you follow those rules, get this down to reduced row echelon form.
I thought it was 4 little more. This is new. Oh. Okay, yeah. I don't understand. So what gives you
Okay. I like the back and forth that I'm hearing. I'm going to start writing out a way to do it. This is not your way to do it. This doesn't have to be the way you did it. I'm just going to go with what I would do, and we'll see if we can follow through. Okay? For those. -8. Those -36. Right, -36, -71, -144, -1.
Working on it.
I think so. I don't know. Oh, -2. Wait. I'm supposed to get together. But that's still. Well, it's the same thing. Oh, it is, okay. So that would be 0 minus 1 well, we get rid of right here. 0 minus 3 plus 7 minus 7. And then well, I was just making sure. If you take 0 minus negative, it's positive.
Correct.
Not there yet.
Should be 142. I think you missed a negative somewhere.
I feel like I missed it. This is one. Oh my goodness. Okay, so how do we get?
Yeah. Row 1, row 3, negative. Check. Row 3 minus 4, row 1. So minus 4 of those, minus 4 of those. Negative 42.
Okay.
Because it's negative 7. Oh, wait, no. You're right. Minus 4, 28, 4. Yeah. Okay. Minus, that one's positive 2. Because you said row 2 minus 4 of these.
Okay.
So still positive 2. And I think that's why this dominoed on you. Because then... Okay. Row 3 plus 4 row 1s. Okay, now that one won't work anymore because I would be adding 4 1s to the 0 spot. That's why we always use row 2 to knock out row 3 after the first stage, because there's a 0 next to it and it won't affect my problem.
Okay, so how would I?
Well, how would you get rid of a negative 12 using a negative 2?
With the 6?
Yeah, so I'll say row 3 minus 6 row 2s.
Okay.
I don't know what I did, but I got 68.
Okay. So add that, negative, add that, negative, add that, negative, check. Row 3 minus 4 row 1s. So row 3 minus 4 of those, minus 4 of those, minus 4 of those, minus 4 of those, check.
Minus a negative 9, so it is positive.
Row 3 minus 6, row 2 is exactly what we were just talking about. Minus 6 of those, gone. Minus 6 of those, negative 71.
But then I divided it by 2, negative 2.
No, negative 71.
What?
Negative 35 minus 6 of these is negative 35 minus 36.
Yeah.
Is negative 71.
Right.
Why are you dividing by 2 won't change that?
Because this one was like 142.
Oh, divide by negative 71 then. It ends up being 1 and 2.
Okay, so
but,
yeah. I
okay.
See what you're saying. I
Okay.
just read it wrong.
And then minus 6 of those, negative 44. This should be a negative 71 and a negative 142. So positive 2, domino. Okay, all right. You're doing it right. You missed a negative. It's okay. Y'all, it is just, I swear, you are doing it right. Don't get frustrated. There is just a negative. The one question that I was asked so far on this, on Remind, was literally, I missed a negative. Okay, everything that I'm seeing is I missed a negative. I said, I forgot to multiply this one by 2 before I added it.
I think we did our own special method that no one can compare.
Yeah.
Okay.
And no, what's wrong with the big answer? I think it's fine. We're not scared of big numbers, right, Stanley?
Okay, add those together, negative, add those together, negative, add those together, negative, add those together, check. Four ones minus.
Maybe we had a different problem.
No, Laura.
Okay, no, just right here.
Yeah?
Don't do that within the same problem, referring to something that you just did in that problem.
I don't understand this. Laura told me what to do.
Okay. Okay, so 4 row
So just don't do
ones.
2 steps and
All right.
well, then do it by yourself.
So here's your problem. Is right away at the beginning, when you tried to say 4 row 1s minus row 3, 4 1s minus a negative 4.
Yeah.
But you're referring to something that you just did that you changed, and then you started using these numbers.
Oh.
That's what I'm saying, is like when you did this step, that should have just been step 1, and then go to the next matrix to do this. Because you started using these numbers, but you used this 1.
We're so silly.
Okay?
Oh, because we used the, okay. Well, we just wanted to include everyone.
Okay, I'm just trying to space these out a little bit. There we go. Okay. I want to walk through when I said that every single one of these can be done in 3 steps. What I mean is 3 matrix sets, but each of them you're doing as much stuff as possible. Okay, it's kind of like you're allowed the 1 suitcase and your carry-on. You cram as much crap into those 2 things as possible, right? First thing I did, I noticed these guys were all divisible by 2, so I'm going to make my life easier by cutting this row in half. Okay, now some of us said row 1 plus row 3 so we could get a 1 up in that command zone. That's perfectly fine. But I can just do 4 of this row and 5 of that row, right? It'll still go away. When I do that, now I have a 1 here. So I'm going to use that 1 to knock out both of these spots. Now, a couple of us ran into this already. Hopefully we're getting why. I can't use this 3 to get rid of this 12. Why not? Because then that 5 would come down into that 0 spot and I would undo the work that I just did. Now, we had to do that in the very first step because of how the problem was set up. Okay, ugly problem, I had to do it. Okay, it's not my fault, my brother made me kind of thing, right? Once I get rid of that, now I'm down to, I have a 1 in this spot. I can use it to knock out the 2 numbers above it. Along the way, are you okay with if something reduces at the end like this, just kind of cheating it in there? If you're not, write a separate matrix. Write a separate matrix to show that step. That works too. Okay? But this is it. This is what I do every single time. Now, if I do this process for my 3 matrices, I'll tell you right now, you are going to end up sometimes having to use big numbers. Sometimes you're going to have to use fractions. If you don't like that, then option 2, gather. Option 2 is to instead do this around the world thing, where you get rid of these 2 in step 1, step 2, step 3, step 4. Okay? If you do that, it works every time. Okay? Like, that involves the least amount of thinking. I'm just going to do this every time. What I'm saying is sometimes as we go through these, we might see at the beginning of the problem that maybe there's a 1 down here. So I'm not going to start here for around the world. I would instead start here for around the world. Okay, I would start here by getting rid of these 2, then use this to get rid of this guy. Then I'd have just a 1 here, so I'd get rid of these 2 guys. Then I'd use this to get rid of this guy. So it's still that same path. It's just I started here instead. Okay? That's what Gauss-Jordan allows us to do. It sets up the framework for how we organize our work, and after that, I get to just kind of follow the rules of the road. Can you go 10 miles an hour under the speed limit everywhere you go? Yes. Most people don't. You know, can you put on your blinker a block and a half before you're going to turn? Yes. Someone's going to annoy you. Okay? Okay. Now, sometimes these come out just like 2 variable systems. Remember that, do I have the physical, nope. Back at the beginning of the year when we talked about 3 variable systems, there was what does 3 variables create? Like, geometrically. Like 2 variables creates what? 2 variables, okay, 3 creates a plane. 2 creates a line. So when I had 2 variable systems, you could have 1 solution, no solution, or what was that called? Infinitely many. Remember, we didn't say all real numbers because this is not on the line. It's not a solution. So it's not all the numbers, it's just a lot of numbers. The same thing is going to happen. These are planes. Think of sheets of paper. The number of ways that sheets of paper could connect. So far, everything that you've been dealing with has a plane like this, a plane just straight up and down like this, and another plane going through it just kind of at an angle. Where they're all going to intersect at just one little point in the middle of three-dimensional space. What happens is sometimes this plane is like floating down here, and these two are going to be parallel instead. There's no place that all three of them are going to intersect. No solution. There might be a place where all three of them intersect infinitely, meaning they're all parallel but just rotated. Think of like, you ever seen those dorky little table decorations where it folds out, like kind of paper mache looking stuff? Think like that, except it's three planes. They're all intersecting on that center line. Well, that's an infinite line, so there's infinitely many solutions. And that line will have an equation. When you the just scathing look over there. When you previously did three variable systems in Algebra 2, when we reviewed it at the beginning of this year, we said you could have one solution, you could have no solution, you could have infinitely many solutions. Well, now we're going to talk about what infinitely many actually looks like, because it's defined based on one of your variables. So step one, I got to write the matrix. So write the matrix. Before I go writing the matrix, do I want to move any of these rows? Like, well, that's an operation. I'm content with it right now because of this. I'm content with it right now. I'm going to just start down in that bottom right corner instead of the upper left corner. Okay? So we got -5, -2, 1, 2. 4, -1, -6, 2, -3, -1, 1, 1. Okay. So like I said, I don't have a 1 up in the command zone. Holly, you are absolutely right. If you want to add rows 2 and 3, or rows 1 and 2, so you get a -1 up there, do it. We are going to race to Walmart. Holly's going to go this way, I'm going to go that way. We'll both meet at the Walmart parking lot. Okay? You're following the rules of the road. As long as you're not like GTA hitting people along the way, you're fine. Okay? I'm going to use this to knock these two out. I'm going to say row 2 plus 6 row 3s. So take this times 6, -18, add it. Take this times 6, -6, add it. Take this times 6 and add it, bye. Take this times 6 and add it. Not going to touch the bottom row. -3, -1, 1, 1. How do I get rid of top row? So I'm going to say, now the order I do it in doesn't matter either. I can say row 1 minus row 2, or row 1 minus row 3, or row 3 minus row 1. Yeah, it doesn't matter. So I'll do like row 1 minus row 3. Negative 5 minus a negative 3. Negative 2 minus a negative 1. 1 minus 1. 2 minus 1.
Oh my gosh. That's
Every time you said that joke, he already means like 7 different.
See, the fun part about it is it's not the 3 leeches anymore, which means he starts at 5.
The leche, un leche. The last leche.
Privileged.
Not privileged.
That is insane.
What's red and bad?
Get like 5 today.
A brick.
That's another one.
So, come on. Now, normally I would use this middle position to get rid of these two, right? But it's a 7. That's not going to be very fun. I'd have to use a fraction. I don't know that we would all like that. Can't I transpose these 2 rows though? So I have the 1 in the middle where they're normally supposed to be. So what I'm going to do is use this guy to knock out these 2, but I'll write it in the second row.
Wait, what? We're gonna write it in the second row.
Remember that I can swap which rows I want at any time? So when I say row 2 minus 7 row 1s, I'll just write it up here instead. So this guy, minus 7 of those, bye-bye. This guy, minus 7 of those, bye-bye. This guy, minus 7 of those. This guy, minus 7 of those. I'll just write negative row 1 here. I'll negate this, 0, negate this. Do you see how now I just have that 1 in that spot? Okay. Yeah, I know. We're getting there. Don't ruin the punchline. No. But do you see how you can use that though? How you can switch the rows as you're going. Okay, now okay, yeah, I can keep going. But Holly is absolutely right. Look at this row. This now says 0 x's plus 0 y's plus 0 z's equals 1. It says 0 equals 1. That is a false statement, so no solution. This is the no solution. Okay? So I want you to write that. If in your matrix you ever get 0, 0, 0 equals number, we'll just say A. If I ever get that where A does not equal 0, that is a no solution. Now, what if I get 0, 0, 0, 0? 0 equals 0, that is infinite, except we don't get to just quit at saying infinite. We get to write our answer in terms of one of the variables. That's the difference between Algebra 2 versus beyond. Okay. So, I'm going to start by writing my matrix. Do I want to rearrange the rows before I get started? Okay. So I'll say row 3 goes up here. Do you want to negate it while we're going? Okay. So I'll say 1, 1, negative 4, 1. But it's not necessary. I'm just asking if that's your preference. 2, 5, negative 2, negative 7. And then we'll put row 1 down here. 3, 5, negative 8, negative 3. Okay. So this one's nice because I've got that 1 up in the command zone. I'm ready to roll. I can use this to knock out the 2 below it. So, let's get going. What is my first set of directions? Okay. Subtract 2 row 1s. So, times the negative 2 and add it. Bye. Times the negative 2 and add it. 3. Times the negative 2 and add it. Times the negative 2 and add it. To get rid of my 3, what's my directions? To get rid of this guy. Yep. Row 3 minus 3 row 1s. Times the negative 3 and add it. Bye. Times the negative 3 and add it. 2 times the negative 3 is now 12 and add it. Times the negative 3 is negative 6. Add it. Or is a negative 3, add them as negative 6. And then I'll just leave row 1 alone for now. Do you notice anything about the rows? Rows 2 and 3 are both divisible, so let's just take care of that now. Or reducible, I should say. So 1/3 row 2, 0, 1, 2, negative 3. 1/2 row 3, and yes, I am, okay, this is why I say 1/2 times the quantity. This is why I said negative 1/71 times the quantity, is because division doesn't exist. Division is not an algebraic structure. I can multiply any row by a thing.
I love it. Oh my god. It's so cute.
Okay.
You just made a joke about eating the brain. No, we didn't.
What's the answer?
Well, you can't write it like that.
Yes, I can. This is called Facebook math. This is how you get 40-year-old Aunt Kathy arguing with someone and like calling out their natural lifeline. No. It's 9. Because multiplication and division are the same thing. There is no such thing as division. You're supposed to have learned that these and these are left to right like a book because division and subtraction don't exist.
No, that is such a big knowledge.
This is 9 times 1/3 times 3. See, what a lot of people will do with this is they'll say 9 over 3 times 3. They'll do these first because multiplication comes first. What you did in that step is you instituted a set of parentheses that wasn't there. Okay? So, yes, division is a lie. It is not a provable algebraic structure. Yeah, when you go far enough in math, as abstract algebra is usually a 4th, 5th year college course where you prove why math works. And division and subtraction are not provable algebraic structures. Like, they legitimately don't exist. Now, they're ideas that we use to communicate in the younger grades, but you big kids now. Okay? Okay. Now we see that they're the same thing. So what's going to happen in the next step when I try to use this to knock out these two? When I say row 3 minus row 2, a row of all zeros. 0, 0, 0, 0. 0, 1, 2, negative 3 is still there. How will I get rid of that 1 in the top row? Row 2 minus row 1 or row 1 minus row 2? The order is just going to change the sign, so I got to know. Okay. Because then it'll be a negative 1, because you're subtracting the 1. Okay. That's why I was asking. Row 1 minus row 2. 1 minus 0 is 1. 1 minus 1 is 0. Negative 4 minus 2 is negative 6. 1 minus negative 3 is 4. Okay. Now, if you used that 2 to try to get rid of that 6 right now, what's going to happen? Right? If I tried to use this to get rid of this, I would undo the work I just did. And then you'd say, okay, well, fine. Now I'll use this to get rid of that. Oh, wait, I undo the work I just did. But then I'll use this to undo and then I just undo the work I just did. You're stuck in the loop. You're the Yorkie chasing a tail, right? So now we come out of the matrix to write our variable answer. That very first line, that says 1x plus 0 y's minus 6 z's is 4. That second line says 1y plus 2 z's is negative 3. And that last line says 0 is 0. This is what tells me that it's an infinite system. This is what helps me write my answer. That's just it. We're writing our answer in terms of z. Our answer is going to have variables instead of coordinates.
My calculator told me like x is equal to 4 plus 6z or something.
Yeah.
So it just tells you the answer. You write that down.
Do you know how to get that, and do you have the work to prove it?
Yeah, I got it.
Do you remember what I said yesterday about if your work doesn't match your answer, I've taken full points off? Okay. All right. What do these two lines, these two equations have in common? They both got z's. That means I can write my answer in terms of z. My x, y, and z of my coordinate. Okay, tell me what x equals. Get x by itself. You can put anything in for z because it's infinite. Add 6 to the other side. X is, they're not like terms, 4 plus 6 Z?
It's just the answer.
The answer is infinite.
So you put like.
There is an infinite number of answers. Well, get y by itself.
So it's subtract.
3 minus 2z. Boop. Yeah. How do I write z in terms of z? How do I write z in terms of z? It's just z.
You open the door, you put the giraffe in the fridge, and you close the door.
Wow. What are you talking
Z.
I don't know why we went like from algebraic structures to
Elephant's in the fridge.
Yo, the giraffe.
Can you take the giraffe out of the fridge?
okay.
Yeah.
So you said like when I say this is infinite, I now mean okay, pick a number. Pick a number for z. That means that 12, negative 3 minus 24, or negative 27. 12 by 6 is 72, by 4 is 76. This is a answer. It is one of the infinite answers. Pick another number for z. Okay? Pick 0. This is an answer to this system. You have an infinite number, and it depends on what button you press for z. That's an infinite system. You can't just quit now. You're big kids. You can't just say infinitely many and be done. Now you're going to write how that infinitely many is represented. You got two of them. I would bet one of them's infinite and one of them's no solution. Now, before you get started, I will show you how to do this on your calculator. This is how you check. I'm going to make this very clear now. I'm going to say it again on test day. Every year there's kids who try to do the matrix. They get through the first like 2 or 3 steps. They BS something in the middle. They make it look like they got the last part. And then they write down the answer that the calculator gave them. If you do that, I'm taking full points off. I can follow your work if you're writing these directions next to them. So if you get it horribly wrong, but I see that you just said 8 plus 6 is 2 back here. All right, 9 out of 10. You ran it all the way to the end zone. You just, I don't know, forgot that it was the wrong end zone. Like you ran the wrong direction. Okay? On your calculator. I'm going to do 6B just because it's over there. Well, on your calculator, if you look right above your reciprocal button, you have matrix. We're going to go over to edit. Edit matrix A. First, you have to determine what the dimensions of this are. How many rows do I have? I got 3 rows. How many columns of values will I have? 4, because we have coefficient and answer. So I'm going to call it a 3 by 4 matrix.
Mine didn't say matrix. I just said F. I think that's probably.
I think you just hit enter instead of going over to edit.
Edit.
Now that I have that matrix set up, I can type in my coefficients. 1, 3, 4, 8, 4, -2, -1, 6, 8, -18, -19, and -2. Okay, so you type in your matrix. What we've been doing with Gauss-Jordan elimination is finding the reduced row echelon form. Quit out of this. You do have to quit or it's just going to keep typing in the matrix. Go back into your matrix menu. Go over to math. And if you scroll far enough down, ref, reduced row echelon form. Go back to matrix and hit enter on matrix A because that's where my data is. It shouldn't have done that. I think I missed. Hold up. I think I typed something wrong. Clear. Second matrix, edit, check my stuff. 1, 3, 4, 8. Oh, this one might just have nasty numbers.
My calculator said no included normal consistent solve.
2, 6. Oh, are those I values? Those are I values, aren't they?
How do we get A?
How do you get what?
A.
Second matrix.
Oh.
Then just enter on A. I think those are imaginary values, and that's why it's coming up that way. That might just be a TI-84 thing. And yes, these are amazing because you can do the whole thing without even looking at it. 3, 4, 8, 4, -2, -1, 6, 8, -18, -19, -2. Yeah, those are imaginary values. That's why it looked that way. I'm trying to highlight it and see the rest of the value, but it's going to be something, 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 something I, because they don't exist. Okay. No solution. Okay, so you can input a matrix into your calculator and then use reduced row echelon form to solve it. That is a great way to check your answer. Not to do the problem, but to check your answer. Especially if you run across one of these on ACT. And you just don't want to go through the whole process. Yeah, both of them. For part A, see how you don't have a 1 up in that top left corner? Could I just multiply rows 2 and 3 by 3 so now it works just like a 1? Okay. Remember, you can multiply rows at any time. So if I got a 3 up in that top left corner, I could just multiply rows 2 and 3 by 3 so that it'll work nicely. Or you can do it as 3 row 1s or 4 row 1s minus 3 row 2s. That'll work too. This is just a way to write it out so there's a little less thinking. That works too. Okay. That's what I'm saying, is that there is so many ways that you can start the problem, that you can work through the problem, that it's very likely in a room of 12, 15 people, we're probably going to have 9, 10 different ways to do the problem. And that's okay. And I know there's a lot of kids who make their way to PreCalc and they hear that and just kind of twitch a little because they're used to just tell me how to do it. And the answer is follow the rules and figure it out. And they don't like that. It's like trying to figure out how to make grandma's donuts when she never wrote down a recipe in 83 years. But it's also accurate. I mean, what we're doing here is a lot of steps, and then it's something happened somewhere along the way. Those are synonymous.
Don't worry, I'm actually gonna do it.
Sure.
Yes, I will.
Like, I'm not joking. Someone's gonna end up with a 0 out of 10 at that point on their test. Okay. No, these will work just fine. Because now, if I take 3 of these and this, they'll cancel. 3 of this and this cancels. 3 of this and this doesn't cancel. So you'll end up with...
That up? 0 right there?
No, because 3 of this is 0, plus 0 is still 0.
Oh, I was looking at one.
Okay. So I'm going to say 3 row 2 minus 4 row 1. let's move this guy out of the way. So, 3 of these minus 4 of those, gone. 3 of these, 6, minus 4 of those is 10. 3 of these is negative 9. Plus 20 is 19. 3 of those is 18. Minus 36 is negative 18. If I say 3 row 3 plus 7 row 1. 3 of these, 7 of those, bye-bye. 3 of these is negative 33. Negative 40 is negative 9. Negative 9. And negative 35 is negative 40. Oh, yeah. 44. Right? 5, 3 of those is negative 9. 7 of those is negative 5 is negative 43. Right? Am I just blanking here? Three of those. Negative 9. Plus 20. There we go. That's why. Negative 9 plus 20. 11. Four, 7, so 5, 3 of these, 12, 7 of those, 63, 12 and 63 is 75. 12, 63, 75.
Okay, go.
All right, the problem down right, is that a 4 there?
It's 3 actually.
Okay, gonna say this should come out clean and it's not. I just wrote the problem wrong.
Me too, Kate.
There we go. Okay, 9 of those, 572. There we go. Okay. Exhaustion and mental math don't go together, especially if you don't write the problem down correctly. What I had showed up there originally was just multiply the bottom 2 rows by 3 and you'll be good to go. This is the same thing, but I'm doing it in one step. 3 times this row minus 4 times that row. 3 times this row plus 7 times that row. I still get rid of those values, but look at what's going to happen when I try to eliminate the bottom piece. Yeah?
Because you need to get rid of the y in that one, don't you?
Yes.
How do you do that? Would you just have to do the whole fancy 10 times 3 thing?
Yep. Which is what I'm about to do. Okay. Please remember as you do this problem, Kate, that this is a PG broadcast. All right. All right, row 3 plus 4, row 2s, and I get bye-bye, 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 bye-bye. Now, yes, I will get rid of that top row by using some of that multiplication crap. I'm going to say 10 row 1s plus row 2. Getting 30, that's times 10, gone. That's a negative 50, and add it is negative 39. That's a 90, and add it is a 72. 0, 10, 11, negative 18. And then I'm stuck in that stage where I'm just going to keep going in circles if I try to do anything further. Well, let's find out. No, stay there. Bad. Okay, I can go matrix. I will edit matrix B this time. I will call it a 3 by 4 again. I'll enter that matrix. 3, negative 1, negative 5, 9, 4, 2, negative 3, 6, negative 7. Wish Frank was faster when we have the streaming software on. 3. I hate you. Three, negative 1, 5, no, 5. So you just like quit partway through? Negative 7, negative 11, 3, come on, Frank. Okay. Double check, everything looks good. Okay. If I have a matrix in here, I can do this for infinite systems too. First I want to quit out of here, go to second matrix. Under math, I am still going to do reduced row echelon form. It won't give me the full answer, but it'll give me most of the answer. Put in matrix B and poke. Do you see what they did compared to what I have? They reduced these all the way down. They divided this row by 10. They divided this row by 30. Okay? Right? 72 over 30, 5, 3, 2.4. That's right. That's right. And 39 over 3 divided by 3, 1.3. Yeah, that's the same thing. What's up? I don't know.
Why is that not the same as what you have?
You didn't finish. You have to get rid of this guy.
Why?
Because otherwise you have an x, y, and a z. You want only two variables. You want z and something else.
So
This row will get you z with a y. You need z with an x. Got to get rid of this guy.
is that right?
Yep.
A lot of weird prices. Row 1.
2 to 5, 9/5. Oh yeah, because it reduces. And then over 4, 12/5. I think. Z, not 0. Yeah.
Maybe not in that matrix. Because it reduces down to the same numbers.
Yes. Yes. Okay. So, like, look at what the calculator is saying. They are doing true reduced row echelon form. They want ones on the diagonal. Something that Owen had just done is had this row as 10, negative 13, and 24. Right? Reducing that row by 3. That is also correct. Because when I take this out of the matrix, I'm going to simplify what I have there. And yes, every year there's some kids who say, I never want to do trig stuff again. There's some kids who say, bring the trig back, please. Okay. Oh, no, don't want that. So, this says 30x minus 39z is 72. That says 10y plus 11z is negative 18, and z equals z. So when you rearrange each of these to write it as an infinite system, write x in terms of z. Add 39 over, divide everything by 30. Reduce by 6, 12, 5. So 12 fifths plus 13 tenths z. No. No, that part will be double positive. I'll subtract 11z over, divide everything by 10. Y is negative 18 tenths is negative 9 fifths minus 11 tenths z, and z is z.
Actually switched there, but I have this is a negative 24.
Should have been positive. That's your problem. 3, 2. Where did this row come from? Oh, okay. Probably all the way back here. Row 2 minus row 1. So 4 minus that, 2 minus that minus that, 6 minus that is negative 3. Interesting. So where else did we use row 1? 10 row 1s minus 3 row 2s. Yeah. Because you're subtracting 3 negative 18s. Means you're adding 72. There you go.
Can we listen to music on the final?
Yeah.
Okay, I read if we could.
Yeah. I got no problem with that. Just device has got to be over there. Okay.
Okay, so once I get to this point, can I just write these two down and already know, like...
You can just be done because 0 does not equal that.
Okay, so I don't even have to fill out this...
Right.
Okay.
Don't even have to finish. Okay. So the final answer is 12 fifths plus 13 tenths z, negative 9 fifths minus 11 tenths z, z. It won't. That's what I just said is this is going to, when you go to reduce row echelon form, it'll give you this. You still have to be cognizant enough that this is an infinite system when you see it to then write x minus 1.3 z is 2.4. Add the 1.3 over there. Isn't that the exact same thing as over tenths and over fifths, right? That this is y plus 1.1 z is negative 1.8. The danger in that is that these were terminating decimals. They're not always going to be. Like, it's a good way to check your answer. It's not going to be perfect. Okay. Now, every year, do not freak out. That was all technically Algebra 2. Four variable infinite. Okay. Now, in the interest of time, we can cut it off there. I know this is a lot of stuff and we're brain fried right now. Okay? Literally feel like you are in the matrix. There's just numbers swirling around you. Okay? I get it. We can just quit there. If you need more practice with them, these are just, hey, do something by Goss Jordan. That is what is critical. Your assignment and your quiz will have a 3 variable infinite, not a 4.
Will we ever see a
Yeah.
4 on the quiz?
Not 4.
3. Will we ever have to do this on the quiz to define like this part?
Yes. Oh, no. No. In fact, on the finalized, okay, on the quiz, I'll have one that says you do it by row operations. In that case, you get to choose if you want to do it like that or if you want to do it in matrix, because both are row operations. Okay? It still has to be structured. It still has to have the directions next to it. And then there'll be one that says must do by Goss Jordan. Then there'll be an infinite or no solution, I don't remember, that says must do by Goss Jordan. And then there's going to be some stuff about multiplying matrices, which is tomorrow, and our partial fractions, which is a little bit of tomorrow and Monday. Okay? And then that's the end. Y'all, this is why kids in Trig and Calc are like, yeah, it's no big deal. Because they went through the portal. They went through the fire, the thing that separates high school math and not high school math. Okay? You, yes, give me my cards back, and you still have to fight Owen.
Yeah, no, we just talked about these like that.
Okay. All right, so we'll just cut it off there. We'll start with 6-2 tomorrow. I'm only going to show you the bare bones of 6-2. I'm not getting into inverses or anything like that. I'm just going to show you matrix multiplication because, again, that's something you should have been shown in Algebra 1. And I know you haven't, so we're going to go through that tomorrow and then get into partial fractions because that is something you will use in calc. Yeah.